Good afternoon, learners. This is Mr. Katsande. Today I am going to be looking at projectiles. This is your physics topic for your paper one, projectiles. So I am sure you have heard one or two things about projectiles, but as we go through them together, you are going to notice that this topic is one of the simplest topics that you can find in paper one. Now, we are going to start by defining projectiles. After we define projectiles, we are also going to look at the two types of projectiles. We just mentioned the two types of projectiles that we have. After mentioning the two types of projectiles that we have, we are only going to deal with one type only. The type that is in your syllabus is the one that we are going to deal with. Now, let us start by defining projectile. What is a projectile? I want you to listen very carefully because these are some of the marks that you can get easily in the exam, because the examiner can ask you to say, define a projectile. When you see an examiner asking you that, the examiner will be wanting to donate marks to you. So you should be gladly accept those marks. Now, define a projectile. What is a projectile? That's where we are going to start with our definition of a projectile. Now, before we come to that, this is an illustration of a projectile. The marker, my marker that I'm throwing up here is illustrating or is representing a projectile. We are noticing that it is leaving my hand. After leaving my hand, it is traveling through air, then it comes back to my hand. So what is a projectile? A projectile is any object. Now, I'm going to underline the word any there, any object. It means that if I am throwing up a marker, that becomes my projectile. If I am throwing up a stone, that becomes my projectile. If I am throwing up a phone, that becomes a projectile. So any object given an initial velocity, any object given an initial velocity, and then it moves with the only force acting on it being the force of gravity. Any object given an initial velocity, or we can put it in another way to simplify it, we can say an object thrown up into the air, an object thrown up into the air where the only force acting on it as it travels is the force of gravity. Any object given an initial velocity, any object given an initial velocity where as it travels, the only force acting on it is the force of gravity. Now, I want us to make an observation here. Is it possible that an object is thrown up into the air and then the only force acting on it is the force of gravity? When we look at it from a science perspective, we can already see that that is not possible, because in air, we know that there are air particles, and that projectile, as it is traveling in air, it is colliding with air particles, which will give us air resistance. So in reality, we know that when we throw an object in air, it is going to be subjected to air resistance. So in reality, it's impossible for us to have an object traveling where the only force acting on it is the force of gravity only. Now, so it means that we make an important assumption. We make an important assumption. There's an assumption that we make here, which we need to mention here as far as projectiles are concerned. What is an assumption? Is something that we are assuming that it is not there, but when we know in reality that it is there. That's what an assumption is. So what assumption do we make when it comes to projectiles? We are assuming that there is no air resistance. This is very, very important that you understand that. So it means that in our syllabus, in all our calculations, we are going to assume that our projectiles are moving in air, but there is no air resistance. It's very, very important that you remember and understand that. So the important assumption that we make as we look at our projectiles is that there is no air resistance during the journey of the projectile. We are assuming that the projectile there is no air resistance during the journey of the projectile. This is a very important assumption because in reality we know that as the projectile is moving, right? As the projectile is moving, we can now take a commercial break.
Okay.
Now, we are making an assumption that there is no air resistance, but in reality, we know that as long as there are air particles around, any object that is moving inside air is going to be subjected to air resistance as it is colliding with air particles. So, in order to simplify our calculations, we assume that there is no air resistance. Now, the other thing that you must know is that for us not to have air resistance, that particular projectile or that particular object that is moving inside air must be moving in a vacuum. So if it is going to be moving in a vacuum, I don't know how and who is going to throw it up in that particular vacuum. Now, this assumption, you must know it to say that as our projectile is moving, where it is moving under the influence of force of gravity only, and we are assuming that there is no air resistance. It's very, very important that you remember this particular assumption that we are making. Now, after this assumption now, we have a phrase that we use to describe the motion of a projectile. Remember, a projectile is a noun, right? You remember your nouns from English. A projectile is a noun. But we have a phrase that we use now to describe the motion of a projectile, to describe the motion of an object which is moving under the influence of the force of gravity only. That phrase is free fall. What is free fall? What is free fall? Free fall is motion under the influence, motion under the influence of gravitational force only. This is very, very important. Sometimes in the exam, the examiner might want to check whether you understand the difference between a projectile and free fall. You must be in a position to understand the difference between a projectile and free fall. A projectile is an object that is given an initial velocity, or an object that is thrown up into the air, and as it travels, the only force acting on it is the force of gravity. So a projectile is an object, while free fall is motion or movement under the influence of gravity only. Now, so a projectile is an object in free fall. We can put it that way to say if our projectile is an object moving under the influence of gravity only, and we describe that motion under the influence of gravity as free fall, therefore we can say that A projectile is an object. A projectile is an object in free fall. A projectile is an object in free fall. It's important that you remember that the difference between free fall and projectile. A projectile is an object given an initial velocity where the only force now acting on it is the force of gravity, and free fall is motion under the influence of force of gravity only. What does this mean now? Because you did your forces in grade 11, you must understand that when you are identifying the forces that are acting on an object and you see that there is only one force acting on a particular object, and that force is the force of gravity, and that object is in motion, then that particular object is a projectile, definitely. Now, there are two types of projectiles. There are two types of projectiles that we need to mention here. The first type is vertical projectiles. These ones are the ones that are in our syllabus, and these ones are the ones that you need to understand very well because you are going to be questioned on them. Vertical projectiles. The other name for vertical projectiles, we call them one-dimensional. One-dimensional projectiles. We call them one-dimensional projectiles. I want you to remember these concepts of one dimension, two dimension. I want you to remember very well those two concepts. When do we say that something is one-dimensional and something is two-dimensional? Now, vertical projectiles, these ones, are projectiles that can only move along the y-axis only. They are going vertically up from the word vertical there. They move along the y-axis only. Their movement is along the y-axis only. So they are going vertically up and then they come back following the same route. They do not have an x component to their movement. So vertical projectiles, they move along the y-axis only. It's very, very important that you understand that. They only have a y component and they do not have an x component. They move vertically up. They move vertically up, move vertically up. Now, there is something that you need to understand on the motion of vertical projectiles here. They move along the y-axis only. You must know that the same route that they use to go up is the route that they will use to come down, right? The same route that they use to go up is the route that they will use to come down. When they are going up following a certain path, they will come down following that particular path. Those type of projectiles are the vertical projectiles, are the projectiles that we are going to be dealing with in your syllabus. The same route that they use going up is the one that they use coming down. I want you to understand a certain aspect here because there is a confusion that learners normally have when we are talking about the movement of these vertical projectiles. When we do a sketch diagram, when we do our sketch diagram, you will find out that our sketch diagram is not exactly in line with this statement here, which says the same route that they used to go up is the same route that they will use to come down. when we do a sketch diagram of our projectile, we are saying that if we throw a projectile up and it comes down, this is our sketch diagram. Sketch diagram. Now, a projectile is being thrown up, it goes up, it reaches maximum height, then it starts falling down. You are noticing that on our sketch diagram here, we are separating the upward arm and the downward arm, but I want you to know that in reality, the same route that it uses to go up is the same route that it will use to come down, right? It is not going to change route and come down following another path. So our vertical projectiles are projectiles that move along the y-axis only, and the same route that they use to go up is the same route that they are going to use to come down. Now, I don't want you to be confused by the sketch diagrams that we use. The reason why we separate the upward arm and the downward arm on our sketch diagram is in order for you to see the upward arm separate from the downward arm. But it doesn't necessarily mean that the route used by the projectile to go up is different from the route used by the projectile to come down. It uses the same route. So these ones are our vertical projectiles, right? These ones are our vertical projectiles, and they are the ones that are in your syllabus. We are going to be looking at them in detail. The other type of projectiles, which is not in your syllabus, and we're just going to mention it here, is your two-dimensional projectile, two-dimensional projectiles. These ones are the type of projectiles where they are moving both along the x-axis and also along the y-axis, two-dimensional projectiles. Now, when you kick a ball, it is not just going to move vertically up. When you kick a ball, it is going to move both along the x-axis and also along the what? The y-axis. They move along both the x-axis and y-axis. Now, if they move both along the x-axis or the y-axis, it means that their movement is going to be represented by the graph that I'm putting on the board. And an example of our two-dimensional projectile is, for example, a kicked ball. For example, a kicked ball. When you kick a ball, as it moves, it is moving both vertically and it also moving both horizontally, right? So the movement of a kicked ball here is two-dimensional, right? The movement of a kicked ball here is two-dimensional. It is showing us what we call two-dimensional projectiles. Now, these ones are difficult to calculate, so we must celebrate, ladies and gentlemen, because this is not in our syllabus. We are not going to look at two-dimensional projectiles, right? They are difficult to calculate. We are only going to limit ourselves to one-dimensional projectiles. We are only going to limit ourselves to one-dimensional projectiles. So we are going to go deeper as we look into these one-dimensional projectiles. Now, I want us now to do some important observations. These observations, as we list them down, they are going to help us in solving projectile problems. These are very important observations, and I call them laws in quotes. I just call them laws, but in reality, they are not laws. I call them laws in order to emphasize their importance when we are dealing with projectiles. When we document them and we master these observations that we are going to talk about here, it means that solving all the problems that we are going to have is going to be very easy for us. Now, let's look at these observations. Observations in brackets, I call them laws. Laws of projectiles. The reason why I call them laws, please take note that my laws is in quotes there, right? Because in reality, they are not laws, but I'm just calling them laws for emphasis to show how important they are and how useful they are in solving our projectiles. These are our observations or laws of projectiles, laws in quotes, because in reality, they are not laws. Now, I want us to look at these observations together one by one. What is it that you observe when I am throwing this projectile up as I am doing? Remember, we defined a projectile and said it is any object. So in this particular case now, my marker here is acting as our projectile. I am throwing it vertically up. What is it that you are observing? Remember, as scientists, you must be in a position to observe, right? To observe. Observation is very important for scientists. What is it that you are observing as I am throwing this marker up? It is leaving my hand, it goes vertically up, right? Then it comes down. What are the observations that we are noticing? These observations are our laws, they are our important laws that are going to assist us in solving projectiles. Now, what are the observations that you can make as a student as this projectile is going up and it is coming down? Right. The first observation that we can see is about the fact that as this projectile gets to its maximum height, what is it doing? It is stopping before it starts falling down. It's a very, very important observation that we need to log in our minds. We are going to use it to solve some given problems. So the first observation is that the velocity of a projectile, at its maximum height is 0. This is very, very important. I want you to log it in your minds. It means that as our projectile is moving, when it gets to its maximum height, it stops. It stops before it starts falling down. The velocity of a projectile at its maximum height is 0. The velocity of a projectile at its maximum height is 0. Please, I want you to log that one in your mind because we are going to use it as we are going to be solving some projectile problems very soon. So, what does it mean when we are observing it? If you look closely as I throw this projectile up, you can see that before it starts falling down, it is stopping, then it starts falling down. So the velocity of this projectile at its maximum height is 0. Where is this coming from? It stops before it starts coming down. Before it starts coming down. It stops before it starts coming down. Now, so we can represent this on our sketch diagram. Remember that sketch diagram that we agreed on to say this is the sketch diagram that we use for our projectiles. I can come here now and say for this projectile, this is my upward arm and my downward arm. Remember what we agreed on. We agreed that the same route or the same path that it uses to go up is the same route or the same path that it will use to come down. But we are noticing that in this particular sketch diagram, this is our maximum height, right? This is our maximum height. Let me just label it with a different color so that you can see it clearly. Right. So that you can see it clearly. This one is our maximum height. Maximum height. That word is self-explanatory. It is the greatest height that our projectile is getting to. This is our maximum height. So we are observing that for all projectiles during their journey, their velocity at maximum height here, the velocity at maximum height here is always, the velocity at maximum height there is always 0. You must remember that. For all projectiles, when they get to their maximum height, they stop first before they start falling down. So their velocity at the maximum height is 0 for all projectiles. We must log that in our minds, because if we forget that, the problem that we are going to have now is you think that the examiner has not given you enough information on your question if you forget that. So you need to remember to say that the velocity at maximum height is 0. That is our observation, a very important observation. Our projectile is stopping before it starts coming down. Now, I want us to move now to the second observation that we are noticing here. The second observation that we are noticing here. I want us to list all these observations. We are going to use them. The second observation that we are noticing here is that if you look closely, and if you have the ability to observe as a scientist, you will notice that the total time taken by this projectile to go up is equal to the total time taken by the projectile to come down. It's very, very important. If it is coming down to the same place where it was thrown from, it's important now. We have got a name for this in science. We call this time symmetry. We call this time symmetry, right? What does it mean when we say time symmetry? It means that whatever amount of time that it is taking to go up is equal to the amount of time that it is going to take to come down to the same height where it was thrown from. Time symmetry. The time taken to go up is equal to the time taken to go up is equal to the time taken to go up. The time taken to go up is equal to the time taken to come down to the spot where it was thrown from. I want you to log that in your minds. It's very, very important. We are going to use it to simplify very, very complicated problems. What are we saying? We are saying that on our sketch diagram of a projectile, if we are going to sketch it, we are separating the upward arm from the downward arm. It means that when I come here and I put a dotted line here, I can label this one upward arm, and this one the downward arm. It's not difficult here. We are just separating them to say this is the route followed by the projectile as it was going up, and this is the route followed by the projectile as it was now coming down. Now, so the time symmetry, this one, is telling us that as the projectile is going up, it is going to have you take delta t up. This is the time taken to go up. And when it was coming down, it would take delta t down here. So time symmetry is telling us that the total time taken by the projectile to go up is equal to the time taken by the projectile to come down. So we can write this in the form of an equation. We are going to say delta t up. We are going to say delta t up is equal to delta t down. I want you to remember this. I want you to log this in your minds, because if you forget this concept, you might think in the exam that the examiner has not given you enough given information. You need to remember this, that the total time taken to go up is equal to the total time taken to to come down. Time symmetry. If our projectile is going to come back to the same height where it was thrown from, it means that we have got some time symmetry that we have. So what does this mean now? It means that the total time, total delta t total is going to be equal to delta t up plus delta t down. Now, our delta t total is going to be equal to delta t up, the time taken to go up, plus the time taken to come down is the sum of the two. But already you can notice something here. If our delta t up is equal to delta t down, it means where there is delta t up, where there is delta t down, we can substitute and put delta t up there. So it means this is still equal to 2 delta t up. The total time taken for this projectile, is equal to double the time taken to go up. This is our second observation, which is a very, very vital and a very important observation. I want you to always remember that, to say the time taken by the projectile to go up is equal to the time taken by the projectile to come down to the same place where it was thrown from. It's very, very important that you remember that. Now, what is the other observation? Please master these observations. We are going to use them to solve very difficult problems that we are going to encounter. When we know these observations, it means the calculations that we are going to do about projectiles, they will become very easy. And you will know which observation is being applied in order to solve a very complicated problem. Now, I want us to go to observation number 3. What is it that you are observing as this projectile is going up and coming down to the place where it was thrown from? What is the third observation that you can see on this particular projectile? It's very, very important that you understand that. Now, the third observation, which is a very, very important observation, is about the size of the velocity of the projectile. Now, when it leaves my hand, I want you to know that when it leaves my hand, it has got the greatest size or the maximum velocity. As it travels going up, its velocity is decreasing until it gets to 0, right? Already we can see that there is a decrease in velocity. As the projectile is leaving my hand going up, its velocity is decreasing until it gets to its maximum height when it stops, right? It's important that you understand that. Now, when it stops now, the size of its velocity will also start to increase, right? It will also start to increase, starting from 0 until it gets to my hand. I want you to remember and know this. If it left my hand at a velocity of 10 meters per second going up, when it comes back to my hand, when it comes back to the same height where it started from, the size of the velocity that it will be traveling at will be equal to 10 meters per second. Let me repeat that. It's very, very important. I want you to master that and remember that. It means that when the projectile leaves my hand at 10 meters per second, it is going up. Remember, as it is going up, its velocity is decreasing until it gets to its maximum height where the velocity will be 0. That is when it stops. Now, when it stops now, when it is now coming down, the velocity will start by from 0 and it will be increasing. When it gets back to my hand, when it gets back to where it was thrown from, its velocity will be the same size as the velocity which it was thrown from. Now, we can phrase that into a very important observation. What are we saying? We are saying that at any given height along the journey of the projectile, right? At any given height along the journey of the projectile, the size of the velocity when going up is equal to the size of the velocity when coming down. We are going to start from the ground here. Remember, the velocity that it starts with is our initial velocity. If we give this initial velocity, for example, we say it is starting at positive 10 meters per second. Let me just write it clearly in a way that you will be able to see. You remember our initial velocity is the velocity of the projectile at the beginning, right? When it leaves my hand. Now, if we say that its initial velocity is positive 10 meters per second, right? And it is going up at any given height along the journey of the projectile, the size of the velocity when going up is equal to the size of the velocity when coming down. What does this mean? It means that its final velocity when it comes back to my hand, its final velocity when it comes back to my hand, it is still going to be equal in size to the velocity that it left my hand with. So its final velocity here, we expect it to be 10 meters per second. But the only difference now, this one is a negative 10 meters per second. If we have taken upward to be positive, it means downward is going to be negative. So the size, the magnitude, it's very, very important that you remember that. Remember, the word size is the same as our word magnitude there. The size of the velocity at any given height along the journey of the projectile. The size of the velocity when going up is equal to the size of the velocity when coming down at any given height. So we have started from the ground here. What it means is that if you throw a projectile up at a velocity of 10 meters per second, it will arrive back on your hand at a velocity of negative 10 meters per second. The size of the velocity when going up is 10. The size of velocity when it's now coming back down is 10. It doesn't apply on the ground alone. It means that if we go slightly up here, remember we have agreed that the velocity as the projectile is going up, the velocity decreases. Why is it decreasing? Because of the force of gravity, which is pulling it down. So it means that if our velocity here is positive 8 meters per second at this particular height, when it arrives back on this height, on its way back, remember it is using the same path, isn't it? So it means that if when it's going up, it arrives here at positive 8 meters per second. When it is now coming down, the velocity that it will be traveling with, this side, it will be minus 8 meters per second. The velocity of the projectile at any given height on its way up is equal in size to the velocity of the projectile on its way down. Let's just give values to this other level now. If the velocity of the projectile going up here is positive 2 meters per second, the velocity of this projectile on this side, it is going to be negative 2 meters per second. Let's put it into a law. What are we saying? At any given side, at any given level, along the journey of a projectile, at any given level along the journey of a projectile, the size of the velocity, when going up is equal to the size when coming down. Is equal to the size when coming down. We will continue from there in our next video. But for those who are watching us from our platform, don't forget to subscribe. See you in our next lesson. Bye-bye.